All right, so 2.3, we're going to look at solving trig equations. And once again, like I said, you need your chart. Your answers are here. The angles that we need are all, and we're gonna focus on the radians. So we're going to be focusing on not that column, this column right here, the radian column. You can also have it in degrees, but we're going to look for radians. But just like Algebra 1, we are going to solve for x. But to do that, we're going to need to get the trig function by itself. So we're going to need sine of x to be by itself so we can figure out what x equals. So first thing I want to do is add sine of x to both sides. So I'm going to add sine x to both sides. That's going to give me 2 sine x. So we have a sine plus another sine gives you 2 sine x. If you had done sine times sine, you would have sine squared. But sine plus sine is 2 sines. So you got 2 sine x, and you still have your plus radical 2 equals a 0. It's nicer to solve them when you got 0. You can see what it looks like. You can see what you need. We know that we're trying, in this case, there's no x squared, so we're just going to try to get the sine by itself here. So I am going to subtract radical 2 on both sides. It's going to give me 2 sine x equals negative radical 2. And I'm going to divide by 2 on both sides. So the 2's will cancel. You'll get sine of x equals negative radical 2 over 2. This is where your chart comes in. You're going to need to look at your chart and find out on your chart where is the sign a negative radical 2 over 2. Where is it negative radical 2 over 2? I'm looking down the sign column, and negative radical 2 over 2 shows up right here. Also down the sign column, there's another one down here. So we're going to need to list all possible answers. In this case, one of your answers is 5 pi over 4. And another answer is 7 pi over 4. So you would go x equals 5 pi over 4. And then x could also equal 7 pi over 4. So 5 pi over 4 and 7 pi over 4 could be your two answers. Let me fix that a little bit so you can see it better. Now the reason I want to fix this is because we're going to need to write some stuff next to it as well. Okay, so those are the two answers that you see on your chart, 5 pi over 4 and 7 pi over 4. Are those the only two answers that you could have? Well, if we were looking between 0 and 2 pi, which is our radians here, if we were looking from 0 radians up here down to 2 pi radians down here, if that was all we were looking at would be this chart right here, then yeah, that would be the only two answers you have. But it doesn't give us an interval up here in the problem. It just says solve. And I know for a fact that in trigonometry, you can go around the circle as many times as you want to. You're allowed to go around and around and around. And we got something we call coterminal angles. So not only would 5 pi over 4 be an answer, but all of the coterminal angles at 5 pi over 4 are also an answer. And I don't have to list them all. I could just simply put plus, oops, if you use your pen, plus 2n pi, and I could put plus 2n pi. Because 2 pi is your rotation, one circular rotation, which makes a coterminal angle, and n is the number of times that you want to go around. So however many times you end up wanting to go around. So in other words, this right here and this right here are just giving us the coterminal angles. It's just basically saying that that any of those coterminal angles will have the same radical 2 over 2 value, negative radical 2 over 2. If I added 2 pi to 5 pi over 4 right here, you added 2 pi to that, it's still going to have the value of negative radical 2 over 2. It would still work in your equation. You'd still be able to go back up to this x up here at this top part, and you'd be able to plug in that angle, and the two sides would still equal. So any of those coterminal angle works. You need to put those coterminal angles on there if they don't give you a specific interval. If they just say to solve it, you need to add that in there. So if you look at number 2 here, the second example, again, they just say to solve it. There is no intervals or anything like that. So we want to get tangent by itself. I would add 1 to both sides. That's going to cancel out. You're going to get 3 tangent squared equals 1. You're going to divide both sides by 3. So you'll get tangent squared equals 1/3. Tangent squared is 1/3. And then you're going to need to square root both sides. So you would square root the 1 and the 3 there. That's how you get rid of an x squared, just like getting rid of a tangent squared is just like getting rid of x squared. And so you're going to end up with tangent of x equals 1, actually, let's put plus or minus 1 over radical 3. Okay, you can't keep the radical on the bottom. You need to do plus or minus when you square root both sides. Because you could have a positive answer that would be, when you square it, would be positive, and a negative answer squared would also be positive. Now we need to get rid of this radical 3 on the bottom. So you're going to get tangent of x equals plus or minus radical 3 over 3. So we need to find where the tangent, in our tangent column on our chart, where is tangent going to be a positive or a negative radical 3 over 3? So if we go back to our chart, where is the tangent a positive or a negative radical 3 over 3? Okay, tangent column this time. So we don't want this column. Oops. We want the tangent column, and radical 3 over 3 is there. There's another one. There's another one. There's another one, because it could be positive or negative. So you actually, on your chart, have 4 answers. You've got pi over 6 is one answer. That's one angle that would work. You got 5 pi over 6 would also work. You have 7 pi over 6 that would work. And you have 11 pi over 6 that would work. So you actually have 4 angles that you could put in there that would actually work. Okay, so let's list those. We'll list those 4 angles. Okay, so pi over 6 was one of them. And I'm going to leave a little space. 5 pi over 6 was the second one. These are all going to have either a positive or a negative radical 3 over 3 for tangent. And then you have 7 pi over 6. And then you have 11 pi over 6. Now I want to show you something on this one that you can do that will shorten up your answer a little bit. You technically don't have to write all 4 of those. Now you could. It's not wrong if you do. If you decide that you want to write all 4 answers and put plus 2n pi, just like we did on this last one, to cover all the coterminal angles, you could do that. Just a little extra writing that you don't have to do all of that. But you could. You could put pi over 6 plus 2n pi, 5 pi over 6 plus 2n pi, 7 pi over 6 plus 2n pi, 11 pi over 6 plus 2n pi. They're all covered. You'd have them all covered. You'd be right. But look at what you can do. Look at what's between pi over 6 and 7 pi over 6. If you look at that on your unit circle, you'll notice that those are halfway apart from each other on the unit circle. They're a half a circle apart. Pi over 6 and 7 pi over 6 are like a half circle away from each other. So they are actually a distance of pi. You see that? 6 pi over 6 would just be pi. It would be 1 pi distance away from each other. 1/6 to 7/6 would be 6/6, which is 1 pi. 5/6 to 11/6 would be another 6/6, which is another pi distance. So instead of writing plus 2n pi, we could just put plus n pi. Because what we're saying here is that if I just have pi over 6 and add a half a circle to it, I'm going to get a right answer of 7 pi over 6. And if I add another pi to it, I'm going to be back to my pi over 6 angle, and then back to my 7. It's going to go in a circle around that. It's going to be covering each one in a half a circle. And then if you did the same thing here, plus n pi, that would cover all the other angles that are 11 pi over 6. So you don't have to write all 4 of them. These could be not written if you didn't want to. You could just have this, and it would be right. Now, it's okay if you want to write all 4 of them and put plus 2n pi after it. That would still work. But if you ever notice that 2 angles have a distance of pi from each other, you could just put n pi. Just shorten it up a little bit if you notice that. So that one still needed us to write all the coterminal angles. Same thing with this one right here. We need to get it equal to 0. So let's subtract 2 cotan first. So minus 2 cotan x first. That's going to give us cotan times cosine squared minus 2 cotan equals 0. Now, can anybody fill me in on what they think a GCF would be there? What do you think is common in both of those terms? You've got a term that has a cotangent times a cosine squared, and you got a term that's got 2 times cotangent. What did I just say twice? Cotangent. That's the common one. So they both have a cotangent. You could divide that by cotangent, and they would cancel out. You could divide that by cotangent, and they'd cancel out. So I'm going to cancel out the cotangent. So that's going to be my GCF, cotangent x. If I cancel out the cotangents, what's left over would be a cosine squared. Here the cotangents would cancel out, but you would still have this negative 2 left over. Do you notice that if you went back to your distributive property, you'd be right back where you started, right? That means you know you did it right. You know you factored okay. If I distribute it, I'd be right back where I started. All right, so how do you multiply 2 numbers together and make a 0 come out? Because when you're multiplying, if they cancel out, you don't get 0, you get 1. So how do you multiply 2 numbers and have a 0 come out? How does that work? You have to multiply this number times this number, this first number times the second number, and it has to get a 0 to come out. What had to be true? How do you get a 0 when you multiply? One of them has to be 0. One of them. We don't know which one, but one of them or both could be 0. But this one might have been 0, or this one might have been 0. One of them has to be 0. So you got to solve both of those equations to get all possible solutions that would give you that 0. So any possible solution that would give you a 0. What would x be to make the cotangent a 0? So look at your chart. We got to go down the cotangent column, and we got to see where x, or where cotangent would be a 0. So if I'm looking at my cotangent column, 0 is right there. And 0 is also down here. So there are 2 places where the cotangent is a 0. Pi over 2 radians and 3 pi over 2 radians. How far apart are those? How far apart is pi over 2 and 3 pi over 2? Subtract them. 3 pi over 2 minus 1 pi over 2. 2 pi over 2, which is just a pi distance. So I don't have to write them both if I don't want to. I can just write the first one and put plus n pi, because they're a pi difference from each other. Okay, so those are a pi apart. So we have pi over 2 was one answer. So I could put pi over 2, and then I could put plus n pi. If I wanted to, I could write them both, pi over 2 and 3 pi over 2. And then I could put plus 2n pi next to both of them. You know, that would be plus 2n pi. It's not as good because it's more compact if you just wrote it like this. But you could write them both with 2n pi's next to them. That would be fine. Adding 2 here gives you cosine squared x equals 2. And if you square root both sides, then cosine x has to be plus or minus radical 2. Now, if I'm looking at my chart, cosine is never a radical 2. Does anybody remember why cosine cannot be radical 2? I mean, if you notice, secant is radical 2, but that's when cosine was radical 2 over 2. So why can't the cosine be just radical 2? What's wrong with putting this radical 2 over here in cosine column? Why is that not allowed? Think about what cosine means. What does it mean to have a cosine? What two sides of the triangle are you dealing with when you have a cosine? Adjacent and hypotenuse. And which one of those is bigger? Hypotenuse always. When the bigger number is on the bottom in a fraction, you can't be greater than 1. Radical 2 is 1.4. That's too big. So cosine will never be radical 2. Cosine will never be plus or minus radical 2. So this x has no solution here. There's no solution that could make cosine become a radical 2. It'll never be a radical 2. So the only answer you really have is pi over 2 plus n pi for that one. All right, moving on to this fourth one. Find all the solutions. Now here's where we're going to start with our intervals here. Okay, so this time you don't have to write the n pi's. You just have to write whatever answers fall between 0 and 2 pi. Here's an interval. I know that's a weird way to write it with a bracket and then a parentheses. But what they're trying to tell you there is just look for the answers that are on your chart. You only want to know what solutions you have that are between those two numbers, 0 and 2 pi, which is just your chart answers. So when you solve this, just get the answers from your chart. Now this one might be more familiar to you if I wrote it like this. 2x squared minus x minus 1 equals 0. You solved hundreds of those in Algebra 1. They probably reviewed it and how to solve those equations. And if you were in my class, since there was a number in front here, we needed a star. And you multiplied the first times the last number, which gave us a -2. The middle number, -1, goes on the bottom, and whatever's in front here is going to go on the top of your star, 2x. I need two numbers that would multiply to give me -2 that would add up to give me -1. So in your mind, you'd be thinking, okay, multiply to give you -2 has to be a 2 and a 1, and they have to be different signs. Adding up to -1 means the bigger one's got to be negative. So I need a -2 with a +1. That's going to give me a -2 when I multiply. It will give me a -1 when I add. The reason we did a star is to see the fractions. Here's one fraction. Can you reduce it? Yes, 1 over 1 reduces. So x minus 1 is one answer. And this one cannot be reduced, so 2x plus 1 is your other answer. If you were to do FOIL, you'd be right back where you started. Our job was to break it down so that there was no x squared term, and now it's gone. You see there are two parentheses, neither one is x. We do the exact same thing in trig. I would actually solve it like this without putting in the signs, because why do I want to write sine a ton of times? Now that I know my parentheses, I can just convert that into sine of x minus 1 and sine of 2x, or no, 2 sine x. Sorry, 2 sine x plus 1 equals 0. So now I can just convert my algebra 1 problem to a trig problem just by putting the sine in front of the x. I want to know what angles would make this equal a 0 here. So I got to find out what's going to make this parenthesis equal to 0. So if I add 1 on both sides, sine of x equals 1. So where is the sine of 1? Here's my chart. Where is the sine a 1? Sine is a 1 at pi over 2, or 90 degrees. Never is it a 1 again on the chart. Now all the coterminal angles would work, but we're not doing coterminal angles because what they said is just give me the answer that's in the interval between 0 and 2 pi. So sine was 1 at 90 degrees or pi over 2 radians. So we're going to put x equals pi over 2. You don't have to put your n pi or anything else because they just want the interval. That's one solution. The other one is going to solve 2 sine x plus 1 equals 0. So we'll subtract 1. 2 sine x equals negative 1 and divide by 2. So where is the sine of x going to be negative a half? Where is the sine of x going to be negative a half? There's probably two answers for that, for negative a half. Because it's a circle, it's going to hit it in two places. So sine is negative a half at 7 pi over 6. Negative a half at 11 pi over 6. Just wants the interval there. That's it. Just the interval. So you have three solutions there that were on the chart. This angle would make the equation work, and both of these angles would also make the equation up here be a right answer. So you could plug those angles in and you would get your 0 on your equation if you solve it. So that was 4. Here's 5. Now watch what happens on this one. Notice how we have a sine squared and we have a cosine. We would like the same trig function. When we factored the last one, they were all the same trig function. And hopefully you know that in your identities by now that your, oh, that's not the one I want, this one. That your identity, your most famous identity, sine squared plus cosine squared equals 1, that your sine squared is 1 minus cosine squared. Okay, so you could take out sine squared and you could put in 1 minus cosine squared in its place. That's what we want to do here so that we can keep our cosines on all of them. So you're going to bring down 1 minus cosine squared. Bring down your 2 in front of that, and you're going to distribute that. So 2 minus 2 cosine squared x. Bring down your plus 3. And bring down your minus 3. Okay, so now we need to combine our like terms because 2 and 3 are both whole numbers. So you would end up with a negative 2 cosine squared. That's still negative in front of that 2. A plus 3 cosine. And we're going to combine the 2 with the negative 3. So 2 minus 3 gives us a negative 1. I don't know if you remember your algebra, but you're not supposed to have a negative in front of your x squared term. That would make it really difficult to FOIL and get that answer. So what they like to do is change that sign to a positive simply by multiplying both sides by negative 1. As long as you're multiplying both sides by negative 1, it stays equal. The cool thing is, on the right side, 0 times negative 1 is still 0, so we don't have to worry about that changing. But you can distribute that -1 to all three of these. You'll get a +2 cosine squared. You'll get a -3 cosine. And you'll get a +1. Now you can factor that. Now you can draw your star again because you got a number in front. 2 times 1 is 2, -3 on the bottom, 2x and 2x. Multiply to give a +2, but they add up to be a -3. Ooh, you got to have two negatives this time, right? You got negative times negative would give me a positive. Negative plus negative would give me the negative at the bottom. So the 2's again can cancel out. You're going to get x minus 1. So we're going to actually get cosine x minus 1. And 2x minus 1 cannot reduce. So 2 cosine x minus 1 equals 0. So we used our factoring, our star, to get the two parentheses. Now we're just going to solve them by setting them both equal to 0. Cosine x minus 1 equals 0. We'll add 1 to both sides. What angle would make the cosine of x equal a 1? What angle makes the cosine of x a 1 is the question. Cosine of x is a 1 at 0. So if you look at your chart, 0 radians. It does not ask for an interval. So you have to list them all. So 0 plus 2n pi. You could leave it like that. But what is 0 plus 2n pi? Just 2n pi. When you add 0 to something, it stays the same. So you could actually have 2n pi for this one, and they would assume that 0 is also a right answer. If you want to make sure they know 0 is a right answer, then you might want to leave the first one as 0 plus 2n pi. But if you're okay with just leaving it n pi and saying n could be 0 rotations, which would leave you with 0 radians, then you could leave it as just n pi. They're both okay. They would both work. Let's try the other parentheses. 2 cosine x minus 1 equals 0. So let's add 1 again. 2 cosine x equals 1. We'll divide by 2. Where is the cosine of x a half? What x value, what angle value is the cosine a half? I'm looking at pi over 3 plus 2n pi. And I'm looking at also 5 pi over 3, way near the bottom. Now, those two I did not put plus n pi because they are not pi apart from each other. Think about how much it would take to get from 1/3 to 5/3. That's not 1 whole, that's 1 1/3, that's 4/3. So I can't put plus n pi, I have to put 2n pi. I need coterminal angles for both of those. They are not a half circle apart. So you have to leave it like this. And then the last one here, your last example, again, is going to give us an interval, which is nice. So we only have to find the answers on our chart. And notice that you've got a cosine and a sine. And it's better if you've just got one trig function to solve for. And there's no identity that takes a sine out and a cosine in its place. But there is one if you have them squared. Remember, if I take out sine squared, I could put in 1 minus cosine squared. Okay, so I need to have it squared, though, to do that. I can't just put sine equals 1 minus cosine. That's not true. It's sine squared that equals 1 minus cosine squared. So for that to help me, what I would need to do is just simply square both sides. So I'm going to take this parenthesis and square it. I'm going to take the sine and square it. And I'm going to write this parenthesis twice. Cosine x plus 1 times cosine x plus 1. That's what squaring a parenthesis means. You're doing FOIL. Cosine times cosine would be cosine squared. Cosine times 1 would be cosine. 1 times cosine would be another cosine. So you got 2 cosines. And then 1 times 1 is 1. So you just did FOIL here just to get your three terms. When you get sine squared, you could actually take it out and put in 1 minus cosine squared. Now you just have cosines and there's not two trig functions. And what's cool is we can combine, we get a 0 by adding cosine squared on both sides and subtracting 1 on both sides. So look what happens. Cosine squared plus cosine squared would be 2 cosine squareds. You're not multiplying them, you're adding them, so it's 2 of them. You got 2 together. You still have the 2 cosines, and the ones cancel. Those cancel, those cancel, it just equals 0. So what's nice, even nicer, is that you do not have to do a star because you only have 2 terms. So just look for a GCF. See if you can divide both of them by something. What can you divide them both by? A 2. Do they both have at least 1 cosine in it? Yep, you can divide it by 2 cosine. So the 2 cancels here. Cosine squared over cosine, you can cancel 1 cosine off the bottom and 1 cosine off the top. So my GCF is a 2 and a cosine. That's the GCF. What's left over would be just a cosine. Not 2 of them. We had 2 on top, but 1 of them got canceled out. So you just have the 1 cosine left. This right here was your GCF. That 2 cosine is what's coming out of both. Here, everything cancels out. And what happens when everything cancels out? It's not 0, it's 1. You get them divide them. When you have the same thing on top and bottom, it's always going to be a 1. So now you've got your 2 parentheses where you can just set them both equal to 0 and solve them. 2 cosine x equals 0, dividing by 2 means the cosine of x has to be 0. So what value of cosine makes a 0 come out, or what angle? That'd be 90 degrees pi over 2, and that would be also 3 pi over 2. So x could equal pi over 2 and 3 pi over 2. Remember, they're asking for an interval this time, so I need to list both answers. I don't need to put plus n pi or anything like that. I just need the answers that are on my chart. So in that case, I'm going to get pi over 2 and 3 pi over 2. When I solve this last one over here, cosine of x plus 1 equals 0, I subtract 1. Cosine of x equals negative 1. And where is the cosine going to be a negative 1? That's just at pi. Cosine is negative 1 at pi. So x equals pi. So there's one solution that's on your chart. There's the other 2 that are on your chart. You don't have to add the coterminal angles. They're not asking for coterminal angles. They just said, give me the answers that range between 0 and pi. Or 0 and 2 pi. If they had said 0 and pi, then you would only have 2 answers. You would just have pi over 2 and pi. Those would be the 2 solutions between 0 and pi. But since they said 0 to 2 pi, you also have 3 pi over 2 as one of your answers as well. All right, that's solving the trig equations.